So in this video, we are going to talk about mole conversions, and we are going to be using the mole, not like the furry creature that lives in the ground or the mole on your face, but a way that we do measurements and amounts in chemistry. So right here we have millimole. Unfortunately, a mole does not look like this super cute character from the American Chemical Society. It is a little bit more mathematically inclined. So let's go ahead and look at the first fact that you need to know in order to do any of these mole conversion problems if you're going from moles to atoms and molecules. The fact that you know is that 1 mole of anything is equal to 6.022 times 10 to the 23 anything. It's like if your mom said, go get a dozen eggs from the store, you're not going to stop and ask and say, well, Mom, how many is a dozen? You're going to know that it's 12. So if I say, go ahead and get a mole of something, you would know that it's 6.022 times 10 to the 23 somethings when we're talking about science. To be more specific, 1 mole is equal to 6.022 times 10 to the 23 atoms or molecules. If it's a singular element, we're going to talk in atoms. If it's a compound, we're going to talk in molecules. So right below here, which is really the part you're watching this video for, we're going to go ahead and do a conversion. So the conversion here is talking about moles to atoms, and we're starting with 7.87. We're going to follow a very similar method to when we did conversions with the metric system. So we're going to go ahead and write 7.87. Make sure I have a big enough decimal place there. Moles Fe. Again, we want to make sure that we're writing all of our units because when we get into the next chapter, we're going to actually start doing a conversion from one type of atom to another. We're not quite there yet, but it's really good to have your units for that. Whatever unit I start with is going to end up being the unit on the bottom because we want them to mathematically cancel. So I'm going to take the mole of Fe and go ahead and put the mole of Fe down here on the bottom. My problem says that I'm going from moles to atoms, so I'm going to go ahead and write my atoms Fe up here. Now the question is, what are the numbers that go in front of the mole? And what are the numbers that go in front of the atoms? Conveniently for us, right here, this is our conversion factor. And it tells us exactly what numbers are supposed to go in front of those units. So for us, it's going to be 1 mole here and 6.022 times 10 to the 23 here. So just a couple of words of warning as you get ready to put this in your calculator. This is a number that is written in scientific notation that we learned at the beginning of the year. You're going to have to put that value in parentheses in your calculator because what it's going to try to do is multiply 7.87 times 6.022 and then multiply the entire thing by 10 to the 23, which is going to steer you in entirely the wrong direction. So you want to make sure that you're entering the 6.022 times 10 to the 23 in your calculator in parentheses. So when we go ahead and enter that in the calculator, we end up with 4.74 times 10 to the 24th atoms of iron, which is Fe. Okay, so at this point, this is a pretty simple, normal question that you're likely to see on your test. Make sure there's a couple things to note. Here, the unit we started with is the unit that ends up on the bottom, and the unit that we wanted ends up at the end on the top. So that's how you know you're going to be right every single time. Also, one thing you want to look at here is the magnitude of the number. This is a really big number. That's a really good thing because there's lots and lots of atoms in 1 mole, and we actually have more than 1 mole here. We actually have 7.87. So that's looking pretty promising. So let's go ahead and try a couple more questions. So here's some practice. 7.87, as we so like this number, times 10 to the 36 atoms of Cu going to moles of Cu. Let me write this little reminder up here for you that 1 mole is equal to 6.022 times 10 to the 23 atoms or molecules. Please note, molecules are not the same as moles. I know it may be tempting to shorten molecules in your mind to moles, but no, don't do it. They're not the same. So don't fall into that trap. Let's go ahead and start by writing with the number that you have first, which is 7.87 times 10 to the 36 atoms of copper. And the first step that I'm going to do is I'm going to take that atom unit that's right here and go ahead and drop it to the bottom of the fraction because we want them to cancel mathematically. So we're going to write atoms, Cu right here. And we know that the mole here, okay, it's going to go up top, so it's going to be moles of Cu. Okay, the number that we're going to associate with moles right now is 1, and the number we're going to associate with atoms is 6.022 times 10 to the 23rd. Okay, so now we're going to put this in our calculator. Another word of warning, we also see 6.022 times 10 to the 23 in scientific notation, but in addition to that, we also have our initial number in scientific notation. So we want to put both of these numbers in scientific notation when we're doing this problem. So I'm going to put 7.87 times 10 to the 36 in my calculator and divide that number by 6.022 times 10 to the 23. I'm going to end up with, in this case, a number that is in, again, 3 significant figures based on this number here. So 1.31 times 10 to the 13 mole Cu. Again, this is a large number, but it's not quite as big as the magnitude of 36 and 23 that we started with. Okay, so here's one that might trip you up at some point. We're starting in moles and we're going to molecules. Again, moles and molecules are not the same thing. Don't fall into the trap. So I have 8.76 moles. H2O is where we're starting. Why? Because that's the number I gave you at the beginning. And now we're going to take that mole H2O and drop that again to the bottom of the fraction because we want it to mathematically cancel. So I'm going to have 1 mole H2O. And we're going to molecules in this case. So I'm going to put molecules H2O. And if we look back up here, I'm going to slide up a little bit. It says 6.022 times 10 to the 23 atoms or molecules. So I can still use my Avogadro's number in this case. Again, fair warning, we want to make sure that we're still putting the 6.022 times 10 to the 23 in parentheses and going ahead and multiplying this by 8.76. Okay. After I multiply all these together, I end up with 5.28. If I'm rounding to the correct number of significant figures, times 10 to the 24th. And this is going to be molecules of H2O. Again, make sure you are filling out your units at the end so that you are getting a complete answer, as that's always a couple of points on the test. So here we have 2 examples. We have the first example going from atoms of Cu and then going to moles of Cu. So the atoms start out on the top because that's the number we start with. They go to the denominator of the fraction in order to cancel out the units. And then moles go on top. The 6.022 times 10 to the 23 is always associated with the atoms because there are more atoms in 1 mole. And then we're going to have, on the bottom one, I have 8.76 moles of H2O. Again, right here, I have the mole from here going to the mole down there. And molecules also, remember, molecules and atoms can be equivalent here because they are both associated with Avogadro's number. So I hope this helps do a little bit of conversion practice from moles and atoms back and forth using Avogadro's number.